Hello, friends. Steve Delamarter and Ralph Lee once again to continue our investigation of how we analyze data with spreadsheet filters. This is the third in a series of 5 videos that is attempting to walk through and explain the wonders of spreadsheets and how it helped our research process tremendously. In this video, then, we'll be applying this capacity of spreadsheets to a question that emerged for us about ETH1 minority variance, or minority variance in the ETH1 period, the 14th to the 16th century, and then what happens to those minority variance from the ETH1 period when we get into the ETH2 period. And it's going to take 2 of these videos to fully explore that. So we'll just get started here with part 1. And we'll be looking at examples from the book of Deuteronomy. The insight that started this investigation was quite profound for us when it began to emerge. And I think in our research, this is often how this goes. We get as much data as we can. We start to get familiar with the data, and we look it over, apply ourselves to it, and start to see some things that may lead to something else. And that's exactly how it played out for us. As we were looking at the data in the book of Deuteronomy, we became aware that there was a digital fingerprint of in the aligned texts that seemed to hold a story. And I'm going to pull over here an example of this from the text viewer. By the way, the text viewer is the single best tool for investigating the phenomena of textual history, because you can see the whole thing laid out here right in front of us, organized by clusters. So when I say a digital fingerprint, look, for instance, at column 1 here. We have a phenomena in which we have pluses up in this cluster, dominated by this cluster, lacking in this cluster, and 1 or 2 more in the early period, and then we don't see it again. So all of this is happening in the 14th to the 16th century. Now, what is this? It's a minority variant. You see, there are 1, 2, 3, 4, 5, 6. Another 7 makes 13, and 5 makes 18. There are 18 manuscripts in the early period here, and only 6, 7, 8 of them have this variant. So that would be a variant that's in a minority of the manuscripts, right? And in this case, then we look down underneath and say, oh, it goes completely away. Now, those are actually, we're going to see 2 different things. But so the first is, wow, we've got a minority variant in the ETH1 period, and it has a certain look here in the text viewer. And once we can spot that, then we say, I see another one just a couple columns later. Look at, we've got another variant, not between a plus and a minus, but between 2 variant readings. Ralph, explain a little bit about what's going on between 3 and 4 here.
Yeah, so again, the reading in column 4 corresponds to a minority of the manuscripts. We've got 7 manuscripts out of the total witnessing to that reading. And in this case, it's a proper variant. It's a different spelling of a word that brings quite a different meaning to the word as well in this particular case.
Yeah, so column 4 then is another example of a minority variant in the ETH1 period. And again, in this case, actually, it's going to get taken up and repeated, though not very much, in the later period by merely 2 manuscripts. It was this first insight that there is a set of phenomena in the text viewer, and it has a digital fingerprint. That is, when you set your eyes to look at it in a certain way, you can start to see these because they have a certain look on the page. We'll do one more here, an example in chapter 7, verse 22b.
Again, this is another example of where a whole cluster goes one way, but still represents a minority of the variant. So the reading that we see in column 2 is a minority variant. it's represented in a minority of the manuscripts of the earliest attested period.
Yeah, and once again, in this case, as you look further, it stops in the
Mm.
early period, and it only appears in this one cluster. And indeed, that's going to become a great diagnostic
Yeah.
for finding manuscripts that are a part of this cluster.
Yeah.
Now, uh, so there's another example where your eyes starts to begin to be able to see these things. We see with witness 26, we have a conflation of the two possible readings, but it still witnesses to this plus that characterizes EA2. So we got this digital fingerprint. And we gave it a name. These are minority variants in the ETH1 period. And we realized that we were going to have to go through. We tried at first to develop a script. Gary worked with us that could sort of do this automatically. If the human eye can see it, maybe we can train or program the computer to be able to see these. And we came up with a version that didn't have enough human intelligence to distinguish between this and that. So it was just giving us so much that we said we're better off just to go through our entire sample of the book
Yeah.
of Deuteronomy and look at every single verse part. And we got faster and faster at this because, once again, we'd seen the digital fingerprint and we knew how to spot these things. But if we're going to go through and do all this, we need to figure out a way to collect data because we want to not just say we saw it, but then create a data set where we can show it again and replicate it. So we needed to track it, and we needed to show the behavior of every manuscript in these developments in the context of clusters, because we saw that it wasn't just manuscripts that were behaving, but sometimes it's entire clusters that are behaving in a certain way. So we said we have to conceive a spreadsheet layout that's going to hold this data. And we began to think and to design a spreadsheet in which we could harvest and visualize the data. Here is that spreadsheet and what it looked like before we started putting data into it. And Ralph, once again, if you wouldn't mind walking us through the design of this spreadsheet.
Yeah, I mean, this is a really important part of the process of using spreadsheets, putting together the data in a way that is meaningful and is also clear. So here, columns represent each manuscript, and we've organized them in clusters. Each row represents a verse or a subverse, a unit that we've analyzed. And we can mark in the columns the presence or not of a minority variant. In this case, we can use this spreadsheet for other forms of data. And perhaps most importantly, we've included the actual text that's represented by the minority variant. So as we process this data, it's always clear what not just the, if you like, the statistics are telling us, but what the text is also telling us.
Yeah, so here's statistics, here's philology, right side by side. And now we're going to fast forward. We're going to show you the empty. We're going to go from the empty spreadsheet to now here's the full spreadsheet. And we have to say it took between 1 and 2 weeks to go through the entire book of Deuteronomy in our sample and look at, spot all of these things, write up the variant, and then fill in dots that represent these are the manuscripts that have the minority variants. And look at this list. It goes on and on. In this case, there are 170, what is it? 73, 78 something examples of minority variants in the ETH1 period. Well, think about that for a second. 173 minority variants in our sample of the oldest manuscripts of Deuteronomy. That is the 14th to the 16th century. And our sample is comprised only of 9.3% of the book of Deuteronomy. We found 173 in 9.3, and you do the cross multiply divide thing, and that suggests that there are going to be somewhere around 1,860 of these phenomena of minority variants in the ETH1 period. Now, you just got to stop and say, that's huge. The ETH1 period is loaded with minority variance. If you ran this thing for the entire book of Deuteronomy, even this 173, which we hope is enough to be representative of this. So here's the population, 1,860. Here's our sample, 173. And our hope is that this will be a large enough sample to enable us to see this phenomena more clearly. Okay.
Yeah.
So looking more closely at the data and began to realize that there is a big divide between the left side of the black line and the right side of the black line. What do we mean by that? You see that we have these smaller black lines that differentiate clusters from one another, but this harder black line represents the old manuscripts, the division between the old manuscripts, the ETH1 period, and then the later manuscripts starting in the 17th century and going on or the standardized text, as we're going to call it. So two text forms, one's over here, one's over here. Chronologically, this is the older part of the tradition, this is the younger part of the tradition. And we saw that there's that these dots, there are one set of questions hovers over these dots and their meaning in the early period. Another set of questions hover over these dots and the later period. So there's this fundamental difference between the distribution and behavior of minority variants in the 14th to the 16th centuries and their level of further adoption or rejection in the 17th to the 20th century. So we saw that when we're looking at now the aggregation of all this data, we need to make a fundamental distinction between the nature of what's going on the left side of that black line and what's going on the right side of that black line. But we also saw that the patterns were too complex to comprehend. So as I pull down this 173 data points or push it up, say, what's the meaning of this data? Meaning is usually associated with patterns of shared variation, right? So I see all kinds of patterns of shared variation. I see these share readings for, a lot. I see bigger patterns over here. I see patterns down here. Well, there's one where we have some here and none over here, and others where we have a few over here and a whole bunch over there. So the point I'm trying to make here is with this sample of 173, it's still really hard to figure out what the patterns of shared variation are. The data is simply too complex to comprehend. We needed to further process the data in a way that would filter it and enable us to see subsets of the data that held the patterns of shared variation that are the meaning, that hold the key to the meaning of what's going on. So Ralph here, who was very familiar, he's a magician when it comes to what you can do with a spreadsheet, trained as he was as an engineer, his first PhD. And we said, I'll bet you we can do that with filters. We've already got it in a spreadsheet, and I know how to make set up filters in this thing where we could get a closer look. So explain what it is that we're going to look at here in this first video we're going to show.
Yeah, so as Steve has pointed out very clearly that there are patterns, and patterns in many cases associated with clusters. So we need to prepare some, if you like, some analysis from our spreadsheet that groups together manuscripts in the groups that we think are relevant. In this case, it's clusters, and then we're going to use some formulas that help us work out the patterns for each manuscript, or rather each cluster and each verse part, and then we can then move on to developing filters to make sense of the data.
So for those of us who have never done this kind of thing before, the thing you have to know about filters is that you don't just do filters. It's a three-step process in which you have to conceive a set of sums, columns, that are going to be in which you're going to need to put sums, and then you're going to need to apply filters to those sums, and then and only then are you prepared to actually begin to filter things. Let's watch the first step in this video.
So now we're going to build some columns of collected data that allow us to apply filters. First thing to think about is what columns are going to be meaningful. And in this case, it's quite simple. We're going to aggregate the data from the clusters. So I need 6 columns inserted over on the right-hand side here. And they're going to have the same titles as our clusters: EA1, EA2, EA3, EA4, Stan, MTR, and Stan2. You could gather any meaningful set of data. The next thing is to use a formula. I've just copied that thing down. You'll see why in a minute. Formula that works well here is called COUNTIF, which is fairly self-explanatory. I enter a range of data, and I can do that by selecting the cells. And then I enter criteria, in this case in speech marks because it's a form of text, to say, and this then says, if in that range I find this character, I'm going to count it. So in this case, the sum comes to 0. Do that once again here, count if. The range this time is going to be for EA2. And the criteria is the same. In this case, it comes to 1. So now I've added that same formula for different ranges right across the clusters. So for instance, here we can see EA4 has 2 dots, and the formula has correctly recorded. So the range is all the cells of EA4 for this particular variant. The next thing to do is to select these and copy them down. And because of the way the ranges are written by default, you'll find that the range corrects itself in all the formulas. So if I copy them down, you'll see that if I look at the cells here, the range is actually has got the correct row number in it. So now we've got our columns of data, and we'll, in a separate video, show you how we're going to apply filters to this data.
So the conceiving that's going on in this step is to say, as I investigate this further, I can see that tracking the behavior of clusters is a necessary part of that. And in order to do that, I need to turn this, to use filters on it, I'm going to need to create cluster sums over here in preparation for creating filters. Is that a good way to put that, Ralph?
Yeah, that's right. And we could create any combination of the data that we wanted to, but in this case, it's clusters that are the things that are mostly governing what we're trying to look at. So
yeah. Okay. So now we're going to show another movie that is the next step. We've created these columns. How, though, do we create filters? And then this movie will also begin to show how we apply filters. So here comes the video.
So having formed these columns, we need to start applying filters. What we do in order to do this is select the range, including the headings, head over to Data, and create a filter. And you'll see that what that does in the headings is add these little triangles. Now, if I click on the triangles, I get a range of values that are found in that column that I can filter with. So you'll see here in EA1, we've got everything from 0 through to 6. So I can apply the filter by clearing the numbers and say, I'm just interested in the 5s and the 6s. And here we go. We find the set of the data that has just those 2 values. And it tells me how many of the rows have met that criteria as well. So one more illustration. Let's say in MTR, I'm interested in cases where only, let's say, 0, 1, and 2 are present. So I clear, select 0, 1, and 2. And here I have those cases left.
So this it showed us both the second and third steps of setting up filters. In the first step, we prepared columns of data to be able to use. In the second step, we apply a filter to it. In the third step, we apply that filter to the data. That's the third step then is everything else. Once we have these in place, we've essentially created a tool that is going to enable us to query the data over and over and over again, looking for patterns and trying to understand what they mean and how to explain them. So in doing this, we've discovered that there's a very specific set of steps that you need to go through. If you just start on the filters punching numbers, you'll get the results to show up on the screen. You'll have no idea what it means or even what you accomplished by pushing the buttons you did. You have to decide, first of all, what is the research question I'm looking for? I want to know how EA1 behaves. Okay, if that's your research question, then decide on the filter settings that will answer that research question. And in this case, you're looking at the filter that's attached to the EA1 columns of things and setting it to either low numbers or high numbers. And then you apply the filter. So this is going to be the process we're going to go through. The data is going to come instantly and easily, and it's kind of easy come, easy go. If there's something there, you get on it. If it doesn't show anything that's comprehensible or coherent, then you just walk away from it. But it requires still analyzing the data to come to comprehend what its patterns mean. So what did we learn from this process? We saw that we needed ways to process and analyze our data at another level. What the scripts that we had written for the THEOT project took us a huge amount of the way toward preparing sets of data, but we still couldn't see all the patterns we need to see. Ralph?
Yeah, and then we became convinced that filtering was the right process and learned that we've got to prepare our data. We've got to prepare it. We've got to format it in a way that is filterable. We've got to design combinations of data that we can filter. And all those steps mean that when we do analyze, when we answer our research question, we will get all of the cases out of our data. We won't just be picking out things piecemeal. We'll be getting all of the examples that match the criteria that fit, and that's the beauty of it.
Yeah. So that kind of covered the second and the third point.
Sorry, Steve.
These steps. No problem. To prepare columns and prepare filters. Another thing that we learned through this process is that we began to see this bigger picture that will come clear in the following two videos, that there's one set of dynamics to be described in the earliest attested period, that of 14th to the 16th century. It's the phenomena of the presence of minority variants and their behavior and their meaning. And that's different from the question, what happens to those minority variants in the standardized period? And that's going to be a different set of conclusions we reach there. So we're in a position now to apply filters and take these next steps. And what's going to happen now, this is the end of this video. In the next video, we'll actually do this live on examples from the book of Deuteronomy to illustrate how we then formulate research questions and then go filter the data and draw conclusions from that. Thank you for your attention. See you in the next video.